Hi guys, today we're going to look at lesson 12.5 compound events. But before we start, let's do a little bit of review with multiplying fractions. This is going to help us out with our lesson for today. So find each product. Remember when we're multiplying fractions that we multiply straight across and simplify at the end. So if we do 3 times 3, we get 9, and 4 times 4 would give us 16. Now, if I look for a common, least common multiple, or excuse me, a greatest common factor of 9 and 16, there is none. It's 1. And so this right here would be our final answer. Here, if we do 3 times 2, we get 6. Multiplying straight across, multiply across here. 7 times 7 is 49. If I look for a greatest common factor between 6 and 49, the GCF is 1 again, so this again is our final answer. We can't divide the numerator and denominator by anything. So a compound event is 2 or more events, and a compound event consists of events that either do or do not depend on each other. So 2 or more events could be like, I get an A on a test and my parents buy me an ice cream. Those are 2 or more events. One event is that I got an A on my test, and the other event is that I got ice cream from it. Or my parents bought me an ice cream. And so the events can depend on each other, but they don't have to depend on each other. So we're going to look today at independent events. And these are 2 events in which the occurrence of one event does not affect the probability of the occurrence of the other. So the example I gave of I got an A on my test, and then my parents bought me an ice cream, that's probably going to be not independent events. That's what we would call dependent, because my parents were so proud of me getting an A that I got an ice cream. If I'd gotten an F as a result, I wouldn't have gotten the ice cream probably. I don't know about you guys. My parents don't buy me ice cream when I get an F on a test. So independent events would be something like I decided to go and get my hair cut, and also it rained. These 2 do not affect one another. The fact that it's not like every time I get my hair cut it rains, and we wouldn't say that every time it rains I get my hair cut. So these would be independent events because they don't affect the probability of the other one happening. So if A and B are independent events, in other words, they don't have an effect on each other, then we can say the probability of getting A, then B, is multiplying these 2 probabilities. So if I use my example from over here, and I say that, A is getting the haircut and B is the rain, the probability of me getting my hair cut and then it rains is I take the probability, what's the probability that I'm going to get my hair cut, and what's the probability that it's going to rain, and I'm going to multiply them together. Now remember, your probabilities are always between 0 and 1. So when we multiply these together, we should end up with another probability that is also between 0 and 1. You can see on our problem here, 3/4 and 3/4, that's 0.75 for each of those. That's between 0 and 1. And our answer is less than 1 because the numerator is smaller than the denominator. Same thing here. Both of these are between 0 and 1. So is our answer. So our probabilities have to be between 0 and 1 to make sure that this happens. All right, so a family wants to have 2 children, a girl and a boy. What is the probability of them having a girl and then having a boy? So in other words, what's the probability of them having a girl and then a boy? Well, these are independent events. The gender of the first child does not affect the gender of the second child. It's not like, oh, you had a girl first, so that means that it's going to increase the likelihood that you have a boy. It's still going to be the same probability. So the probability of having a girl is 1/2. Either it's a girl or it's not. And then we're going to multiply it. The probability of having a boy is also 1/2 because either it's a boy or it's not. And when we multiply these together, we're going to get 1/4. So we could say 1/4 would be a good probability. You could also, we've been practicing putting our probabilities into decimals. So you could also say 0.25. You do not have to write both of these, just pick one or the other. You roll a 6-sided die. What is the probability of rolling a 3 and then a 5? So the probability of getting 3, then 5. So this is kind of what we talked about with expected value. If I roll a 3, it doesn't mean that it increases the probability of me getting a 5. The probability stays the same. We're not using expected probabilities here, we're using theoretical. So the probability of me getting a 3, there's only 1 3 on a die out of 6 sides. For the 5, there's only 1 5 out of 6 sides. So when we multiply these together, it's going to be 1 out of 36. And you can leave your answer like that. You can also write your answer as a decimal. And if we do 1 divided by 36, we get, calculator slow, sorry. There we go. We get 0.0, and I'm going to write what my calculator looks like. My calculator looks like this. We're starting to forget how to round. So when we're doing probability, I like rounding to 3 numbers after the decimal. So here's 1, 2, 3. So I'm going to cut it off right here, but I got to look at this last number. Is this number here? Let me pick a slightly different color. Oops, sorry guys. Sorry, technical difficulties. All right. Is this number here going to round this number up or down? Or leave it, I mean. It's going to round it up because it's greater than 5. So really, if you're writing your decimal, you need to make sure that you're paying attention to the numbers, and it would round it up to 0.028. And again, you can give me this answer or this answer. You do not have to give me both. All right. You draw 2 shapes at random from the right. What is the probability that you draw a circle, put it back, and then draw a triangle? So try this one, pause the video, and then come back and check your work. All right, so from the shapes that are here, how many of them are circles? We've got 1, 2, 3 circles. So there are 3 circles out of 7 shapes. There's 7 shapes in total. To get a triangle, there are 1, 2, 3, 4. So we're going to do times 4 out of 7. Because again, there are 7 shapes. So this is showing the probability of getting a circle. Then, we're out of room, triangle. I should have written that first, sorry. So when I multiply these together, 3 times 4 gives me 12. 7 times 7 gives me 49. So that can be my final answer. Again, if you really like decimals, I like decimals, I think that they're good to use with probability. We've got 12 divided by 49, which is 0.244897 ... Oh, that should be a 7. So I'm going to put 3 decimal places, and then this 8 is going to round the 4 up. So I'm going to get 0.245. Always use your rounding rules. So dependent events would be things like the test, getting an A, and then the ice cream. Yay! And so there are 2 events where the occurrence of one affects the probability of the occurrence of the other. So if B depends on A, if my getting ice cream depends on me getting an A on the test, the probability of B happening is, we say, what's the probability of A, and then multiply it by the probability of B after A. So what's the probability of A happening? What's the probability of me getting an A on the test? And then what's the probability of me getting ice cream after that first thing has happened? So you write out the word Nicaragua, then cut out each letter. You put the letters in a cup and mix it up. What is the probability that you draw an R, don't replace the letter, and then an A? So first let's start with the R. So they're saying what's the probability of getting an R, then an A. Now the difference between this and the one with the circles and triangles is that this time it tells us that we're not going to replace it. So to start with, how many R's are in Nicaragua? 1. So 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. But then, what is the probability of getting an A after we've taken out the R? Well, there are 1, 2, 3 A's. But now, because we took out R, we're subtracting 1. We took out 1 letter, so we subtract 1, and we're left with 8 letters now. It's like we said, okay, what's the probability of getting A now out of this? Aren't you glad there's an A in the country name? That looks a little weird. There are 8 letters, and 3 of them are A's. So we're going to multiply these together. We get 3 out of 72. Well, I can actually simplify this one. I can divide them both by 3. So we're going to get 1 over 24. So that can be our final answer. If you want the decimal answer, we're going to do 1 divided by 24 in our calculator. And we get 0.041. And then it's 66, so I'm going to round that up to 417. And that could also be my answer. You pull out all of the diamonds from a deck of cards. What is the probability of drawing the 3 of diamonds? And then a face card without replacing any cards. So the first question is, how many cards are we dealing with? If you pull out all of the diamonds, there's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, and king. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the probability of getting a 3 and then a face card is 1 out of 13. And then we're saying, okay, now that 3 is gone, what's the probability of getting a face card? Well, there's 3. Jack, queen, and king all have a face on them. So there's 3. But now, instead of being out of 13, we took out the 3. So now it's out of 12. So we've got to do some multiplying here. We're going to have 3 over 13 times 12, which is 156. And again, I can divide by 3 on top and bottom, which is going to give me 1 over 52. And if I do 1 divided by 52 to get my decimal, I'll get 0.019. It's 0.192, so that 9 is going to stay the same. So try this one and see what you get, and then come back and check your answer. All right, so we draw 2 shapes at random. What's the probability that we draw a circle and then draw a triangle, but this time without replacing? So we did this one when we did replace it, but we're saying, okay, probability of getting a circle, then triangle, but this time again without replacing. So the probability of getting a circle first is still 3 out of 7. But now we're saying, okay, we did get a circle, so that one is gone. We only took 1 of them out though, not all 3 of them. So we drew 1 circle, and now we're drawing again. So now there are 4 triangles out of 1, 2, 3, 4, 5, 6 shapes. So we're going to have times 4 out of 6. This is going to give us 12 over 56. And we can simplify this. We're going to divide both the top and bottom by, I think, by 4. And so what we're going to get is 3 over 16. Is that right? No, 14, sorry. We get 3 out of 14. And then when we do 3 divided by 14, we get 0.214.